today we are working on limit questions. It's been a minute since we've done them. First period, they all came in and just sat there and stared at the board. I'd like us to remember how to do them. Okay. Don't forget, limits were easy. The main concept with limits were that I take whatever I have and I plug it in. Okay. When in doubt, just plug in, do direct substitution. So on a question like this, I'm going to plug in infinity on top and on bottom. Where is it bigger if I plug in infinity, on top or on bottom? On top is bigger. Okay, because on top I'm doing infinity to the fourth power. So if the number on top is going to be bigger, it is going to keep growing and growing and growing. What value are we going to get closer and closer to? Infinity. And if we get closer and closer to infinity, what's true about our limit? It does not exist. They might every once in a while sneak in infinity there. We're going to say does not exist. Bigger on top does not exist. What if it would have been bigger on bottom? Then it'd be 0. And if they were the same, that's when we looked at leading coefficients, things like that. Let's go to the next one, -1. We take -1, we plug it in. What do I get when I plug -1 on top? -2. What happens when I plug -1 on bottom? 0, -2 over 0. That is undefined. So what is my limit? DNE. What happens if I were to flip that thing and I would have gotten 0 over -2? What does 0 over -2 get you? That's 0. But we got 0 on bottom, D and E. Easy. Keep rolling here. We're doing the next one. We're taking -3. I am plugging it in. So I take -3, I plug it in. On top, I plug in -3. I get 9 minus 12 plus 3. I get 0. I take -3 on bottom, I plug it in. I get 9 minus 15 plus 6. It gets me 0. I get 0 over 0. What does that mean? It means I am not done. 0 over 0 is called indeterminate form. We don't know. It could be 0. It could be D and E. It could be something else. Okay, remember when we get 0 over 0, that tells us we are then going to factor, cancel, and plug back in. So we are going to factor that thing. On top, we can factor that into x plus 3 and x plus 1. On bottom, we can factor that into x plus 3 and x plus 2. So we got 0 over 0. If that's true, we got to do more. So we factored. Now we're going to cancel. And then we're going to plug back in. -3 plus 1 is -2. -3 plus 2, -1. My answer is 2. That's not too bad. Try the last one. See what you can do with the last one now that we've reviewed. Talk with your neighbor again. So we're trying to find the limit as x approaches 0, so we could always just take 0, and we could plug it in. If I plug in 0 on top, it gets me 2 minus 2. What is e to the 0 going to get me? 1. So, okay, cool. On top, I get 0. On bottom, I'm doing sine of 0. What's sine of 0 going to get me? It's 0 over 0. Oh no, I got 0 over 0. Well, we just learned. On the last one, you got 0 over 0. We factor, we cancel, we plug back in. So, uh-oh. Can we factor this very well? You could take out a 2, but that doesn't really help me. I can't really do anything. I can't cancel. So factor, canceling, plug back in doesn't work all the time. There are some things that we can't factor and cancel with. That leads us to today. Today, we're going to learn L'Hopital's rule. Okay? L'Hopital. L'Hopital is an interesting dude. I don't really like a lot about the history of math, but this guy's an interesting guy. He was pretty good at math. I would not say he was like the greatest math person of all time, even though he has like a lot of things in his name. He's got a rule named after him that we're learning a lot of years later. He stole it from some farmers. I don't know what they were doing on their farm, but they were doing some calculus apparently. And he's like, oh, I like your ideas. I'm going to borrow those. And they said, okay. And then he wrote a whole book. And then like at the very end was like, oh yeah, these guys did this. And I wrote a book about it. But He's got a rule named after him, so he wins, I guess. His spelling of his name looks like that, L'Hopital. Notice that there's a cool little hat on the O. Anybody remember what that's called? In French class? No? All right. His name when he was alive was that, and he changed it to not have the S in it anymore. It's weird. Okay, so it's La Hospital's rule, but we can go with L'Hopital. It helps you to spell it, though. L'Hopital. All right. Here's what L'Hopital's rule says. Okay, L'Hopital's rule can be applied when you're doing a limit problem of a fraction and you get 0 over 0. Okay, if you're getting 0 over 0, you can use L'Hopital's rule. You can also use it when you're getting infinity over infinity. We don't use this one as much because we have other ways of solving that. But we could use it then as well. But 0 over 0, we're using L'Hopital's rule. Here's what L'Hopital's rule says. It says if you're doing a function, a limit, and you're getting 0 over 0, then that answer, the limit to that problem, is going to be the same as the limit of the derivative over its derivative. Okay, so here's what we're going to do. Let's find the limit as x approaches 2. We take 2. We plug it in on top and bottom. If I plug in 2 on top, what am I going to get? 0. If I plug in 2 on bottom, what am I going to get? 0. I get 0 over 0. So right now, if we get 0 over 0, the thing we would do is we would factor. So we'd say the limit as x approaches 2. We could factor the top, x plus 2 and x minus 2. We factored the top. The bottom, I already got x minus 2. What could I do? Cancel that out. I factored, I canceled, and now I need to plug it back in. Take 2, plug it in. What is the limit of this problem going to be? 4. Done. There's my answer. Okay, we factored, we canceled, we plugged back in. That works fine. But we can also use L'Hopital's rule. Again, L'Hopital's rule says that if this is an answer, it's going to be the same as the derivatives. So again, we start this problem. All right, cool, I'm getting 0 over 0. So if I'm getting 0 over 0, I could also just take the derivative of the top. What is the derivative of x squared minus 4 going to get me? 2x. And if I take the derivative of x minus 2, it'd be 1. We take the derivative, we plug it in, I get 4. Neither of them are hard. L'Hopital's rule is probably easier because you don't have to factor. If it's that simple, just taking the derivative there is pretty straightforward. Make sense on how this works? Let's do it. Okay, so example number 2, evaluate this limit. Technically, there's a long drawn-out process that you could factor this problem, but I didn't even teach it to you because it's way easier to use L'Hopital. Okay, if we started off, we plugged in 0. It'd be the square root of 1 minus 1. That'd be 0, all over 0. Okay, we get 0 over 0. So then we normally would factor, cancel, plug back in. Can't do that. So we're going to do L'Hopital's rule. Okay, so we're going to find the limit as x approaches 0. Square root of 1 plus x minus 1. I got to take the derivative of that. Remember, that's the same thing as 1 plus x to the 1/2 power. 1 plus x to the 1/2 power. Luke, what's the derivative of that going to be? Good. He's doing chain rule. He multiplied by the exponent 1/2. He rewrote the baby. He subtracted 1 from his exponent. Technically, then we would take the derivative of the baby. But what's the derivative of baby? 1, so it didn't really do anything for me. So that's my answer. The minus 1 goes away. And then I would take the derivative of x. What would the derivative of x be? 1. That's my derivative. All I need to do now is take 0 and plug it in. Okay? Your brain might not like that, but remember it's just this. 1 plus, oh, it's a negative square root. That's 1 plus x on bottom. Okay? That's the same thing. If I plug in 0 there, it's like plugging in 0 here. What am I going to get for my final answer? a half, because it's 1 plus 0. Square root of 1 is 1. 1 half times 1. My answer is 1 half. Question, Jan? Okay. So, again, this is the same as this. So all I did was I said, oh, this is 1. All I did was rewrite it so it was easier to do. 1 plus x to the negative 1 half. The negative power puts it on bottom, right? The negative power put it on bottom, and it was 1 half, so it was square root. So I just rewrote this. 1 half, I put the 1 on top, the 2 on bottom, and I rewrote that thing on bottom just to make it easier to plug in. That's all I did. Let's look at 3. Number 3, we're finding the limit as x approaches infinity. Technically, we don't even need L'Hopital's rule. We're just going to use our brains and be smart here. Okay? If I plugged infinity on top and bottom, are they going to be the same value? No. Technically, if we plugged in infinity on top, it would be infinity. And if I plugged infinity on, it's infinity. But we know that there's different levels of infinity, at least a little bit, as dumb as that sounds. Which value would be bigger, the top or the bottom? The top. Okay, because it's an exponential function. E to the infinity power is a much bigger number than just infinity. Okay, so if it's bigger on top, what am I going to end up getting? The answer is D and E. But we could use L'Hopital's rule. Okay, we just used our brain there and thought, oh yeah, exponential functions are bigger than just x. But technically, we're using L'Hopital's rule. Okay, because if I took the derivative, so if I get infinity over infinity, I can use L'Hopital. Limit as x approaches infinity. Ah, that's an infinity sign, I swear. Okay. E to the 2x minus 1. I'm taking the derivative. Andrew, what's the derivative e to the 2x going to get me? Good. The derivative e is what you see times the derivative of the exponent times 2. And on bottom, the derivative of x would just be 1. If I plug in infinity now, oh, it'd be infinity over 1. Oh, yeah, that's d and e. Okay, they might look the same right here, but they're not. The top is bigger. So if you weren't sure, you could always take the derivative on top and bottom and do it. Our brains work probably a little bit better just saying, hey, the top is going to be bigger because it's an exponential function than the other. Questions on 3? Try 4 with your neighbor. Go. There we go. 1 limit as x approaches 0. In order to use L'Hopital, it's not always L'Hopital, okay, but we got to make sure it's 0 over 0. Okay, so we plug in. It is 1 minus cosine of 0. Don't forget what cosine of 0 means. Here's 0. What is cosine going to be right there? 1. So it is 1 minus 1. That gets me 0. On bottom, it'd be 0 plus 0 squared. That gets me 0. Cool, I got 0 over 0. Let's do L'Hopital rule. Okay, so if I'm doing L'Hopital, the limit as x approaches 0. Michael, what's the derivative on top going to be? That is sine of x. Good. The derivative of 1 goes away, and then he is taking the derivative of negative cosine. That is sine x. Remember, Snapchat, negative Snapchat. He's right here at negative cosine, so when he goes back that way, we're to sine, which is what we want. Okay? Then we take the derivative on bottom, x plus x squared. Jacob, what's the derivative of x plus x squared going to get me? 1 plus 2x. Good. 1 plus 2x. Derivative of x is 1. X squared becomes 2x. Then we're just plugging in. You are taking 0. You're plugging it in. What is sine of 0 going to be? That's 0 because we're out here and we want the y value. If I get the y value right there, it's 0. And then 1 plus 0 would get me 0 over 1. What is the answer to this question? It is 0. Questions on 4. Try number 5. See what you get. Limit as x approaches 0. We're plugging in 0. Okay, so if I plug in 0 on top, I get 1 minus cosine at 0. We just did that. That's going to get me 0. On bottom, it's 0 squared. That's going to get me 0. Great. If I get 0 over 0, I'm using L'Hopital's rule. Okay, so we're going to take the derivative, the limit, as x approaches 0. Jonah, what's the derivative on top going to get me? Sine x. Good. The 1 goes away. And again, negative cosine becomes sine x. On bottom, Cannon, what's the derivative going to be? 2x. That's our derivative. So once we found the derivative, all we have left to do here is plug in 0. If I plug in 0, sine at 0 is going to get me 0. 2 times 0 is going to get me 0. So we did L'Hopital's rule. It didn't finish. It got me 0 over 0. Our rule is that if we get 0 over 0, we're not done. We've got to keep working here, okay? This has not happened very much on the AP exam. I don't know if I've ever seen one doing this, but it's easy. Okay, if I get 0 over 0, I just apply L'Hopital's rule again. I'm going to take the derivative again. Okay, so the limit as x approaches 0. I'm taking the derivative here. Lulu, what's the derivative of sine going to get me? That is cosine x. Good. And then the derivative of 2x would get me 2. She took the derivative. We plug in 0. So cosine at 0 is 1 over 2. My answer is 1/2. Sometimes when we do these problems, they can look like magic gibberish. Okay? Like, what did we just do? There's a whole lot of things going on. Why did we just do any of that? And a quick reminder of what we just did. Okay? If I set up that fraction, okay, if I just did what we typed in, 1 minus cosine x on top, and on bottom, what we had, x squared? Yeah, x squared. Here's that graph. What we did was we found the limit at 0. So if I found the limit at 0, it's like I was doing this and getting closer and closer. Oh, do you see it in there when I do it? There it goes, undefined. I can't get 0, it's undefined. We're finding the limit. I want to know what we're approaching from both sides. Okay, so as we approach from both sides, what number are we getting closer and closer to as I get closer and closer to 0? It's a half, 0.499. That's what we're trying to do. Kind of, again, don't lose sight as to what we're doing. We're finding the limit. Okay, it's undefined there. That's why when we plug in, we get 0 over 0. We found the limit as we did it. All right, flip this over to the backside. L'Hopital's questions are pretty common on the free response part. Okay, they are the most annoying to make sure you're justifying correctly because you don't really need to do anything. You just want to jump into it. Like on the front side, we just jumped into these problems. Okay, I student taught for the calculus teacher in Avon. He is like the head calculus teacher in the United States. Okay, last year when we all went on quarantine, he was making the videos for AP College Board for everybody in the United States. He was the one making them for calculus. Okay, so he's way up there. Okay, talking about grading this exam. Okay, when we grade it, they normally all go to St. Louis or somewhere right around there, Kansas City, and they take all of the tests from the entire country and they sit down with a bunch of calculus teachers and they grade them. Okay, in 2018, there was a L'Hopital question on there. Him and his table graded a total of 10,000 tests. 10,000 of that question. Guess how many of the 10,000 kids got all of the points on the L'Hopital's question? One kid. The problem is easy. You already know how to do L'Hopital. It's easy. It's the justification that we screw up on. Okay? In years past, I haven't been clear enough on it. I'm telling you right now, I guarantee you there is a L'Hopital question on your next test. On the free response, there's going to be a L'Hopital question. You got to answer it correctly. Here are the 4 things that you need to make sure you do. Okay? When we see a L'Hopital question, when you look at a free response and you see the limit of a fraction, it's going to be L'Hopital. There's like a 95% chance it's true. Okay, so treat it like a L'Hopital question. Okay, so the first thing we have to do is we have to state the function is continuous. Just right off the bat, you see a L'Hopital or you see a limit problem, state that the function is continuous. We have to show that the limit of the top and bottom are equal to 0 separately. That's the most annoying part. I hate that they do that, but we're going to do it. Yes, sir. Yes, there'll be somewhere in there that it states that. We've got to use limit notation. Okay, so we have to write the limit stuff. You already pretty much do that, but don't forget it. Okay, and then the last thing we have to do is we have to state by L'Hopital's rule. Those are the 4 elements. When we do it here, it'll make more sense. If it's a multiple choice question and not a free response, just do it like we did on the front. We just did it. Okay, but if it's free response, I'm going into free response mode, and I'm going to make sure I hit those 4 things. Okay, so it says the function satisfies f of 0 is 20. Selected values of f prime are shown in the table. F has a continuous second derivative for all these numbers. Find the limit of this thing. So as soon as I read this problem and I see this setup, I am going to go into free response mode. So I'm going to find the limit as x approaches 0 of the top. And then I'm also going to write the limit as x approaches 0 of the bottom. You have to do it separately. It's super annoying. I don't know why they make you do that, but we're going to do it anyways. Okay? We separate those things. Let's do it. So we're finding the limit as x approaches 0 of the top. So I'm going to take 0. I'm going to plug it in. So it says I'm finding f of 0. What is f of 0 going to be? It's 20. Careful, what's that table telling us? That's telling us f prime. It says right there, f of 0 is 20. Cool, so this is 20. Minus 20 times e to the 0. What is e to the 0 going to get me? 1. So it's 20 minus 20. I get 0. So the limit as x approaches 0 on top is 0. We're going to do the same thing on bottom. So it's 0.5. F of 0, what's f of 0 going to get me? 20. So 0.5 times 20 minus 10. Half of 20 minus 10 is going to get me 0. So I got 0 over 0. We already do that. We're kind of going to assume that it's 0 over 0 anyways. We just got to show it, and we have to show it separately, and we had to write limit as x approaches 0. Okay? Once I've done that, now I'm going to transition to L'Hopital's rule. Okay, so we're going to say since. What do you think we need to say is continuous here? F of x. That's the only function really involved. Everything else is continuous. So we're going to say since f is continuous. And we know that because it says it right there. Since f is continuous by L'Hopital. You don't have to be a perfect speller. Again, you could put La Hospital and you're good. It's La Hospital. Since f is continuous by L'Hopital's rule, and now we're going to do it. Okay? We are just going to take the derivative. So we're going to find the limit as x approaches 0. The derivative on top. What is the derivative of f of x going to get me? F prime of x. Minus 20 e to the x. So 20 is a constant. That's going to hang out. What's the derivative of e? What you see. Derivative of e is what you see. Derivative of the exponent. So what's the derivative of the exponent? 1. So it's just that. It's f prime of x minus 20 e to the x. Now I'm going to take the derivative of the bottom. 0.5 is a constant. It's going to hang out. The derivative of f is f prime. The derivative of negative 10. Nothing. Good. So we did that. So then let's find that limit. So if I find that limit, f prime at 0. What is f prime at 0 going to get me? 4. It says it right there. So it's 4 minus 20 times e to the 0. So it's minus 20 because e to the 0 is 1. So it's 4 minus 20 on top. And on bottom, it's 0.5 times 4. You could leave your answer just like that. That's perfectly fine. It's free response. We got an answer. Okay? We could simplify that, though. 4 minus 20 is negative 16. Half of 4 is 2. My answer is negative 8. But you could have left it before we've simplified. Again, here are the 4 things that we had to show. You had to do limit notation. You had to find the limit of each separately and show that it's equal to 0. Then we had to say it was continuous, and then we had to use L'Hopital's rule. If you got those 4 elements, then you're just finding the answer. Questions on the first one? Let's go to the second one. 2 graphs are given to the right, and they're differentiable at 3. Find the limit as x approaches 3. Okay, so start off. You're finding the limit as x approaches 3 of f of x. And you're going to find the limit as x approaches 3 of g of x. Do the problem. Go. Talk with your neighbor. Get it done. We're finding the limit as x approaches 3. Limit as x approaches 3. Looking at this table. Okay? Show me with your fingers. What is the limit as x approaches 3 of f of x? 0. What am I looking for on this table? Just the y value. That's 0. This is 0. G and f both are 0. Cool. Since that is true, we're going to say since. Which function do you think we have to talk about? Both. Since f and g are continuous. And we know that because it says they're differentiable. Since f and g are continuous by L'Hopital, the limit as x approaches 3, then I'm going to take the derivative of the top. What's the derivative of f going to get me? F prime of x. What's the derivative of the bottom going to get me? G prime of x. What am I going to look for on this graph to tell me what the derivative of f is at 3? The slope. Show me with your fingers. What'd you get? Should be negative 3/2. I went down 1, 2, 3 over 2. So my slope on top is negative 3/2 over g prime. Show me with your fingers. What do you find for g prime at 3? Good. It is 1/2. Pick points that you know, like that point to that point. I had to go up 1 over 2, so it's 1/2. If you're not good at fractions, put a box around it, call it the end. Okay? Or you could say, hey, I'm going to multiply by the reciprocal since I'm dividing by a fraction. My answer is negative 3. Make sense there? Try one more. Do that last one for me, please. Here we go. So we're finding the limit as x approaches 1. It's a fraction. I'm going to do it separately. So f of x. And the limit as x approaches 1 of the bottom. So on bottom, it's x cubed minus 1. I'm plugging in 1. What is f of 1 going to get me? 0. It tells me that right here. On bottom, it's 1 minus 1. It's also going to get me 0. Since I got 0 over 0, I'm using L'Hopital's rule. We're going to say since f is continuous. I know it's continuous because they told me the derivative. Since f is continuous by L'Hopital, we're going to take the derivative. So we're finding the limit as x approaches 1. On top, the derivative is f prime of x. On bottom, what's my derivative going to be? 3x squared. What is f prime of, what could I write instead of f prime of x? 1 minus y, this right here. So it's going to be 1 minus my y value. I'm taking 1, I'm plugging it in. What's y going to be? 0. And on bottom, it is 3. It is 1/3.